Good afternoon. My name is Tanmay Kayande, and for the last decade, I've been the trusted advisor for executives from startups to SMBs to enterprise-scale organizations. I've found patterns in the architecture of those that lead their field, and I know because I've designed and developed their systems and processes, using AI, platforms, models, and frameworks to positively affect billions of users, and now bring my insights to you. Welcome to Session 9. So far, all the prompting techniques we've discussed have relied on knowledge already stored inside the model. But what if the model needs new real-time information to answer a question? What if it could do things like search the internet or use a calculator? That's exactly what we're going to explore today. By the end of this session, you'll be able to define ReAct or reason and act prompting and the prompting paradigm of it. The second, you'll be able to explain how ReAct enables LLMs to solve complex tasks by combining reasoning with external tools. To get there, we'll cover a few key ideas: what ReAct stands for and what it does, how it works using a thought-action loop, and how it represents foundational steps towards building AI agents. If you're following along with the white paper, this is between pages 37 to 39. So what is ReAct? It's a powerful paradigm that enables large language models to solve complex tasks by combining their internal natural language reasoning with actions. These actions allow the model to use external tools like a search engine, a code interpreter, or a calculator to find the information it doesn't already have. ReAct mimics how humans operate in the real world, as we often reason verbally and then take actions to gain new information to solve a problem. ReAct works by creating a thought-action loop, which follows a clear, repeatable cycle. Thought: the LLM first reasons about the problem and generates a plan of action. Act: it then performs an action from its plan, like calling an external API to perform the search. Observation: the model observes the result of the information it gets back from that action, and it then uses that observation to update its reasoning, generate a new thought, and plan its next action. This process continues until the LLM reaches a final solution. This ability to interact with external tools and APIs is a first critical step towards creating more advanced AI agents that can perform complex tasks in the digital world. While the white paper provides a Metallica-based example on pages 38 to 39, here's a finance-related example. If you were to share your company's financials with your AI and say, our Q4 budget is over by 15%, fix it, it would guess at the approach to take. However, using ReAct, your new prompt could be, our Q4 budget is 15% over. Think about what's driving the overage, investigate each area, then decide on cuts. Behind the scenes, the AI will reason and act in something like the steps below. Thought: need to identify the biggest cost drivers. Action: review expense categories. Observation: marketing is up 40%, headcount is up 10%. Thought: marketing overage is the main issue. Action: cut non-essential marketing spend. Final: reduce budget by 15%. The model didn't just know the answer, it reasoned out a plan and then acted on it to figure it out. Let's do a quick check. Imagine you ask an AI, what is the current price of a single share of Microsoft stock multiplied by the current temperature in London in Fahrenheit? How would a ReAct agent solve this? A ReAct agent would have to perform multiple actions. First, it would use a search tool to get the current stock price. Next, it would use a weather API or another search tool to get the current temperature in London. Finally, it would use a calculator tool to multiply the two numbers together and convert it into Fahrenheit for the final answer. The main thing to remember is that ReAct gives models the ability to use external tools. It works in a thought-action-observation loop that allows it to reason about a problem and then act to find new information until it can solve it. All these techniques we've discussed require us, the humans, to carefully engineer the prompts. But wouldn't it be nice if an AI could help us write better prompts? In our next session, we'll look at that as automatic prompt engineering. Thank you. I'll see you there.